everybody, and welcome to Statistics, AHA, or ARG. Thank you again for your well wishes the other day, and I'm sorry that I wasn't able to actually hold our webinar. Hopefully this will suffice in terms of helping you solidify your understanding of the material. I'm not sure how long I'll be talking, but I imagine maybe an hour to an hour and a half. I've graded nearly everybody's homeworks, and most folks did quite well. And so I would encourage you to watch parts of this as you see fit. Some of this material may be rudimentary for you at this point, and for others, it may still help you to, again, solidify your learning of the key concepts. So I would leave it to you as adult learners to go through and pick and choose what material to listen to. But my hope is that I've tried to simplify the material for you and really hone in on exactly what I think you need to know for the purpose of moving forward. So as a starting point, let's see if I can get this to advance. I'm not sure why. Let's do it that way. Okay, so what I'm going to be discussing is there are a number of general and specific ideas. One is this notion, again, of descriptive versus inferential statistics. We'll be talking about some basic terminology, that is variable, population, sample statistic, the notion of sampling and sampling error, the mean and standard deviation as, quote, the biggies in descriptive statistics. One of the biggest takeaways, if not maybe the main takeaway that I want you to get from our first three chapters, is what the mean is, what the standard deviation is in terms of representing variability within your data. And because many, if not, I would argue most, maybe even all journal articles include the mean and standard deviation as their key descriptive statistics. So even in just understanding what they are, you can go a very long way in being able to read journal articles and in even being able to create your own mean and standard deviation for your data sets and reporting them in a way that really bolsters your study. Also, how to use Excel to do some basic calculations. I'm specifically going to do the mean and standard deviation. I think everybody knows how to do it already, but it should be that Excel has made all this very easy in a lot of ways. And so I'd like you to, as one key learning outcome, be able to create those two in Excel. Some other ideas, sampling distribution, the notion of confidence interval, and I will review the homework as well. To be sure, these videos will end up showing up likely in separate chunks because unfortunately YouTube only accommodates up to 15-minute videos. Okay, so I want you to think big picture. I don't expect you to calculate a lot of these formulas, except the mean, and I'd even say standard deviation, that is via Excel. But I would not expect you to take all those calculations in the book and be able to do them by hand. The goal in showing you formulas is just so you understand what in essence is being done in them and why they represent what they represent. So for example, with standard deviation, by seeing how standard deviation is calculated, you can better understand why it's important to understanding variability within a data set. So luckily Excel and other programs like what's called SPSS do the calculations for us, making our job easy. So you just need to be able to think intuitively about why the formulas exist and what they tell us about data. And that goes for all of our exercises going forward. I'll let you know if I need you to be able to calculate some things. I might need you to do it once for the purpose of getting a basic understanding of what you're doing. But beyond that, there are a ton of formulas in that book that I would not expect you to know. And frankly, you don't need to. Okay, also keep in mind how statistics fits with the course. And to be sure, statistics fit with the quantitatively oriented and mixed method studies, and essentially starts with the data collection and analysis phases of research design. So one thing that I want you to be thinking about is the fact that you've learned a ton beyond the statistics piece. Statistics really is just one part of the package and only relates with the quantitative and mixed method studies. So, we spent a good amount of time in class talking about research design in general and the qualitative studies. And so you need to, again, feel confident that, hey, I've learned a lot and this is a complement to particular types of designs and starts with latter phases of, or I wouldn't even necessarily say latter, but certain phases of research design. Now, in terms of learning statistics, there are three things that we're after. One is that you get a basic understanding of some of the concepts. Two is an ability to, quote, see them while reading research and know what they mean. Because a lot of understanding research comes down to being able to say, oh, okay, well, here are a bunch of means, here are a bunch of standard deviations, and what do they signal about the findings per the author or your own studies. Also is an ability to actually do the statistics if you were able to undertake a quantitative study. Now, this, I know that some of you may be, quote, quant jocks, and so this will be appealing to you. You will be able, probably by the end of this, our semester, to do more statistics than you would think. And that is my goal, that is my hope for you, because in order, going back to the title of this class, understanding and applying research, in an ideal world, you are versatile. You are able to do a quantitative or mixed method study depending on what kind of question you're asking and what kind of issue you're trying to address. So the most versatile and capable researchers are those who have at least a basic understanding of statistics. So my hope is you will feel at the end of this like, hey, I got more than I actually thought in a short period of time. And I also want you to give yourself a little bit of a break at the onset here in recognizing what I told you during our residency period, which is this class is super aggressive. Really, this could be multiple classes in one. And it's because of the nature of understanding and applying research. We are, as I talked about, taking a very aggressive approach to this class because the aggressive approach is so very, very, very relevant to your capstones. So I just want you to realize when you're completing the rest of these exercises, when you're muddying through all of this, that you're learning a ton. You're really learning a ton, and you're learning what people learn in their doctoral programs over time. And I really feel good about where we are in the class thus far in terms of what we've covered. Okay. One in the know tidbit is that data usually is considered plural. Sometimes people say data is, but usually it's data are. So instead of saying I've collected data and it suggests, you would say I've collected data and they suggest. Again, not everybody does that, but and it's fine if they don't from a everyday colloquial standpoint, but technically data are plural. Okay, so to show you what I was talking about in terms of quantitative and mixed method studies, remember during the residency we talked about these classic stages, and so we spent a lot of time talking about how to identify research questions, conduct a literature review, specify the purpose of your research, and then get to very specific research questions or hypotheses. This is where statistics really starts to come in. And by the way, I probably should have Wikipedia'd this or dictionary.com, numerize, who knows? Who knows if I've stated that correctly? But, for example, in the Das and Long article on what makes research interesting, they were trying to figure out, what makes research interesting. And in terms of, so that was the specific research question. And one way they started to consider statistics was to create a Likert scale of 1 to 4 that respondents would use to answer what attributes were interesting. 1 being uninteresting or unimportant to interesting research, 4 being very important or extremely important to being interesting in terms of research. So once you start to think about how do I create a number that I can capture and analyze, which is really what we talked about in class around when you do hypothesis testing, you're trying to collect data that is in numbers, right? Because that's what you analyze in statistics. So that's where it starts to come in. And then also it obviously comes in throughout the data collection piece, because you're going to have, as an example, survey data with a bunch of numbers, fill in how satisfied am I with my job, Likert scale 1 through 4. Again, a number. And then you will statistically analyze that. So this is really where it comes in. One reason I wanted to highlight where it comes in is because the exciting piece is no matter what, in quantitative and mixed method studies, you already know how to do this. So you've already known a lot without even ever getting to the statistics piece in these two types of particular studies. Okay, I also want to highlight the objectives, learning objectives, going so that you can be sure you know exactly what I'm looking for in this particular case. So I wrote here, below are the most important things that you need to know for the purpose of understanding research. And this is with the first 3 chapters that I had you read. And I highly recommend that in addition to these, you understand pretty much all the terminology in chapter 1 so that you could be able to explain it to somebody. But as long as you understand these things below, the biggies, must know, you can move along to the other chapters. So first is understand and explain the meaning behind the notion of mean and standard deviation as descriptive statistics. Because as I said, virtually all quantitative papers report these 2 statistics. Thus, going forward, you can be pretty confident in reading quantitative papers and mixed methods papers just by knowing these 2 stats. The second is that you be able to calculate the mean and standard deviation using Excel. And, I'll show you in Excel shortly, but essentially the mean equals the average and then the row or the column summed, or the points of data or datum in each of the cells summed. And then standard deviation is STDEV, parentheses, row or column summed. And so we'll go through that. I'd like you to understand the difference between descriptive and inferential statistics. That's really important. Understand what these 3 concepts mean: population, statistic, and variables. Explain what sample error means and why it's important. Understand the notion of sampling distribution. Understand why confidence intervals exist, and know that having a large sample helps. Essentially, number 8, the bottom line is, as long as you have a pretty large sample, you can have more confidence in your findings. So that's why people love big data sets, because it gives them more confidence that they have enough data to make strong conclusions. So the bigger the better in terms of data sizes. And good to know is this notion of normal distribution, right and left skewedness as distribution shapes, which you saw in the chapters. Also, this notion of the central limit theorem. Let me put a little period there. And how to measure how skewed your data are. Excuse me. These, I would say, are all good to know, particularly this one. Not 100% relevant. This stuff is the big stuff to know. So with that said, let's continue on. Okay. So what are a population, a sample, and a variable? As you noted in chapter 1, these are really kind of biggies. And so the population is all the members of a group you want to draw conclusions about. So for example, in your study, if you did a quantitative or mixed method study, you might want to draw conclusions about all coaches, all executive coaches, all of them out there, however many thousands are out there. Now, your sample is the part of the population from which you gain data. And as you know, it's obviously a much smaller subset of the general population. And the key